In this video we have to calculate the E cell for a cell made of strontium and magnesium. In this oxidation reduction reaction, strontium solid gets converted to strontium plus 2 dissolved in water, and magnesium plus 2 dissolved in water gets converted to magnesium. So they give us the equilibrium constant times 10 to the 12, very, very large. So the reaction is pointing this way, predominantly the product side. We would expect a positive voltage. The reason why we would expect a positive voltage is because of the very large equilibrium constant. So let's break apart this oxidation reduction reaction into the oxidation component and the reduction component. So the first thing we have is strontium solid going to strontium plus 2. Okay, to balance this, we will have 2 electrons. Let's just go ahead and make this one arrow. We can put the equilibrium arrow back later in the final part of the problem. So strontium losing 2 electrons. So here, these are all gaining electrons. Let's go find strontium here. Here is strontium, and that is gaining 2 electrons is minus 2.89 volts. Here we're losing those 2 electrons, so we got to flip the sign. So flipping the reaction, flip the sign, that's positive 2.89 volts. And then we have magnesium plus 2, that's going to magnesium plus 2, that's going to magnesium solid. So actually this should be magnesium solid. And we will balance that with 2 electrons. So you see what we did here. Plus 2 minus 2 is 0. Minus 2 plus 2 is 0. Here we lost 2 electrons. Here we gained 2 electrons. And so magnesium gaining 2 electrons to become magnesium solid. That's right here in our reduction table. And here it's going to be minus 2.37 volts. Here we just read it off the table because it's a reduction half reaction, and the table is for reduction half reactions. The 2 electrons cancel. We are left with Mg plus 2 aqueous plus strontium solid. Here magnesium plus 2 is getting reduced to magnesium solid, and strontium solid losing 2 electrons gets oxidized to strontium plus 2, and 2.89 minus 2.37 volts gives us positive 0.52 volts, and that should be our answer here. So the E cell for this reaction is positive 0.52 volts. It's asking for a calculation of E for this cell, and that is going to be our correct answer. So if you want to write this in a galvanic cell notation: anode, salt bridge, cathode. So what is our anode? You lose electrons, so this is our anode. So Sr solid, one line, goes to Sr plus 2. Here's our salt bridge. Cathode, magnesium plus 2, goes to Mg solid. And this is a spontaneous battery that will yield 0.52 volts, of which this is our cathode losing electrons, this is our anode, this is our anode losing electrons, this is our cathode gaining electrons. Here we lost 2 electrons, here we gained 2 electrons. Anode lose electrons, cathode gain electrons.